start. And I'll... So welcome to the final session of today's instalment of Interact Virtual Festival, designing human-centered AI products with Jess Holbrook, who's joining us early from Seattle. Jess is founder and co-lead of Google's People and AI Research Group, who focus on making AI partnerships productive, enjoyable, and fair. So in this talk, he'll discuss understanding the role of UX in the AI design process, methods and best practices for using a human-centered approach to AI, and stories from Google and their industry partners who are trying to implement all of this in shipping products. If you've got any questions, please use the Q&A box, and I'll try and reach as many as I can at the end. And if there's any issues with audio, anything like that, just let us know in the chat function, and I'll do my very best to get that fixed. And yeah, please chat amongst yourselves in the chat function as well. And yeah, I'll hand over to Jess to kick things off.
Great, thank you. Thank you very much. Hello, everyone. Good morning, good afternoon, good evening. First of all, housekeeping here. I'm gonna get my setup all ready so you can see the talk. All right, looks like we are good to go there. I hope everyone can see. Somebody please shout at me on if the people can't see what's going on here. Yeah, thank you. Yeah, my name is Jess. I co-lead one of the groups at Google called the People Plus AI Research Group. And today I kind of switched up the title and the thrust of the talk a little bit, and hopefully it's extra interesting for everyone. And the talk I'm going to give today is called AI is Human-Centered, Whether We Recognize It or Not. And one of the things I'm going to try to convince you of today is the role of humans and the role of user experience at every facet of the AI development process, deployment process, and use process. So to get us going, this is one of the visuals we really like that represents deep learning. And it's a way to show that, over the last 8 or so years, we've had huge gains in the performance of deep networks, specifically, usually this goes by machine learning or AI. I'll use those terms interchangeably for this talk, although they're not equivalent, in a pure sense. So we've already seen huge gains in things like personalization and recommendation around songs you like to hear or videos or movies you might like to watch. We've seen them applied to really interesting prediction use cases. So this is an example from Google Flights, where an ML model is used to predict the change in fare in a flight and when you should purchase a ticket. We're also seeing it enable more creators on a lot of our platforms to engage with their different audiences and frankly just talk to people. This is an example of us doing a little text prediction and making it easier for people to reply to people who watch their videos on YouTube. And then there's some really exciting accessibility use cases. So this is one that is running all on the device, and it's able to recognize different products in the store for somebody who might not be able to easily differentiate between these and find what they're looking for. Of course, there's the canonical case of the self-driving cars, which are enabled by a number of systems, machine learning being one of them. And then there's some use cases that are really exciting. One that I'm especially excited about is our new flood forecasting models that are enabling governments and municipalities and frankly just people and citizens to better predict seasonal flooding, getting people out of the way and quite literally saving lives. And so when a lot of these use cases are talked about in the press or in the public, they're often framed really from the angle of computer science. There's a very much a mathiness veneer to a lot of this. And it seems like it's this system existing away from people and not involving people. And that's almost touted as a good thing sometimes, or goal that we're trying to go for. And I'm going to try to convince you of the opposite. And one of the pieces of this is that we have to recognize that human judgments drive virtually every facet of AI, and humans are involved in almost the entire development process of AI, whether we talk about it or not. So this is the extremely, extremely simplified version of the development and deployment process that we kind of look at. So in any kind of ML model, if you have supervised, unsupervised, or reinforcement learning, just sticking with those three big ones right now, you have training data that are collected and labeled. You have a model that is trained on that data and evaluated and built. And then you have some kind of prediction at the end, whether that's predicting the song you want, or whether you should take a left turn at the stop sign, or whether we think a flood will come sooner or later. And then this kind of loops back, and oftentimes systems use those reactions to predictions as future training data. But the thing is, we choose the data sources we use. That's a human decision. There's no automated system for that. We determine the evaluation metrics. So we decide when a model is good enough or not good enough. And we decide when it's deployed or not. And then we get affected by the results of these predictions. So when I listen to a song, this is not an event that just occurs in a vacuum. It's something that changes the next song I might want to see. So a human decision and a human reaction is involved at every single step of this process, whether we really call that out or not. And so this insight, or whatever you want to call it, was one of the reasons that we started the People Plus AI research group at Google. So we already kind of gave you our jingle jangle there. That's our website if you want to see what we work on. And I like to really frame this as we do three things and kind of explain why we do this. So first, we conduct and publish human AI interaction research. So we publish and we really focus on academic journals. And the thing that we're trying to do there is do really cutting edge research that influences the field both academically and at an industry level. And we have some examples here, like examining one of the BERT models, which is one of the more recent language models, and then the People Plus AI guidebook, which I'm going to talk a lot about in this talk. The second thing that we do is we create and launch open source tools and platforms to build AI responsibly. So it's fine to do the publications and to try to show a better way and a more responsible way to create AI, build AI. But it's not really fair to anybody to say you're doing it wrong, but I'm not going to give you the tools to do it right. So one of the things we try to do is build the tools so people can build in a more responsible way if they want. And here are two examples here. The what if tool at the top, which allows you to look at things like counterfactuals in your data sets, and then the embedding projector below, which allows you to navigate the embedding space for a given model. And three, we try to widen the circle of who can participate in the development and application of AI. So at the top there, you see something called Teachable Machine, which is really great. If you've never seen it, it allows you to train an AI ML model in your browser very quickly using your webcam. It was something that was built on top of TensorFlow.js, which our team built by some great friends of ours at the Creative Lab at Google. And then we do a lot of publishing. So on the bottom right there is a Medium channel that we started that's trying to just explain a lot of topics and explore a lot of relevant topics in human-centered AI to allow more and more people, UXers, product people, even engineers who care a lot about the responsibility of what they're building, to engage in that conversation and start to participate. And you can see that it's three distinct efforts that really, if you want to, if you go back to the three diamonds that that I was showing before, you have to really engage at all three of these levels if you want to make a difference. If you engage at only one, you're not really going to move the needle and move things into a more human-centered place, or at least even recognizing it's a human-centered place. And so one of the big efforts that we have behind that is this thing that we call the People Plus AI guidebook. So it was written to help user experience professionals and product managers follow a human-centered approach to AI. And it really walks through the entire process, looking at how we might build AI and ML in a more human-centered way. And for a lot of the rest of the talk, I'm going to get into some of the specific suggestions we give in here. So the guidebook is not very philosophical. It's very tactical. So it basically says, do this, do that. You know, the way that we thought about it when we were writing it was, we want somebody to be able to read something in the guidebook in the morning and change the way they work in the afternoon. So the guidebook is really split up into 6 chapters: user needs and defining success, data collection and evaluation, explainability and trust, errors and failing gracefully, mental models, and feedback and control. For anyone in the audience who has a human-centered design background, a lot of this should sound really familiar, and it's supposed to. One of the other things we said is, if you're really well trained in human-centered design, probably 30% of the guidebook is boring to you. And that's fine, because we thought that that was the right hook and scaffolding for a lot of these concepts. For the talk today, I'm going to focus on 3 insights from 3 different chapters in the guidebook that hopefully you can take away and kind of change the way you're looking at the way you build machine learning or AI products. So the first is user needs and defining success. And in this chapter, we really start from that classic human-centered design concept of finding a user need and then defining what success is. And one of the central things that we're trying to get people to shift from is this approach of, can we use AI to blank? And shifting that question to, how might we solve for blank? And can AI solve this problem in a unique way? There's been a huge rush to assume that AI or machine learning are the best solution to every problem. And they're just absolutely not. You know, they're very broadly usable general technology that can probably be applied to many problems, and probably many problems we're not thinking about. But if we start with the solution and try to find the problem, we know that we're going to be kind of doing things in the opposite direction. We can talk a little bit there of space for invention. So that's something our team does as well, which is really creating a solution and looking for a problem in a way. But that's something that should be a minority case. It should be small experimentation where we know that there are lots of problems to solve and we need to solve them. But we can also solve them with heuristic systems. So one of the ways that we do this on our team is just a simple 2x2, super easy. We might generate a whole bunch of ideas on the team, or we'll work with a product team like this. And then we really line things up by user impact and machine learning need. So low to high user impact, and then does the solution require machine learning or not? And oftentimes the thing that we look for is, what can Google uniquely do, not kind of a me too or a follow-on thing. And that usually lands in this top right square. So the user impact is very high, and it's only possible through machine learning, or the accuracy or the user experience we want to have happen is only possible through machine learning. And those are the things we try to tackle first. We also try to tackle things in the top left quadrant, so high user impact but no machine learning need as well. And we try to avoid, when possible, the ones that are in the lower right of low user impact and high machine learning need, because that's just kind of a science project. We also have some, in the guidebook, some quick shortcuts for, is AI a good fit or not? And there's no, of course, crystal totally decided upon answer here, right? It's an evolving field. But we find that, AI or machine learning is probably better, when you're doing something like some kind of anomaly detection, personalization, of course, prediction of future events that you have a good reason to believe would be well predicted based on historical events. That's a very important caveat there. And then natural language understanding, things like that, that's just have never been able to be cracked through heuristic approaches. AI is probably not better when you have a couple conditions. One, errors are extremely costly. You can at least have a very strong human in the loop or human intervention on there, but if any kind of error is very costly, you probably don't want to give up that amount of control. When transparency is extremely important. So the story of the black AI is a black box and we don't know what's going on is kind of dated. And we're starting to open it up in lots of different ways. And there's a lot of reason to believe that we'll be able to have explainable AI that meets the needs of everyone. But if you need perfect transparency, like a perfect trail of every I don't want to call it, it's hard not to anthropomorphize it, but every kind of decision made in the code, then AI probably not better. Predictability. So AI, a lot of times, especially with personalization, intentionally changes things. And if you need pure predictability, that's the most important thing. AI might not be better. And then my favorite one is when people tell you they don't want it. So we still, a lot of times companies or products will try to add AI or ML when people are explicitly saying they don't want that, or they don't want that, that characteristic to the product. So kind of listen to your customers, listen to your users there. And here's an example we were mentioning with from one of the articles on our actually Google Design Collection, which is around predictability. So without AI or ML, if the first experience was something you tap, you scroll, you're trying to find an item there. It's exactly the same as the nth experience. And so what you're able to do is habituate. You're able to build up some memory and start to do that faster, start to use less memory, less working memory to do that task. Now, when AI is introduced, the first and the nth experiences differ. The options are re-ranked, and now they're resorted, trying to predict what you'll pick next. But if it's wrong, you're going to break that habituation, and the person's going to have to use a whole bunch of additional mental capacity to to find what they were looking for. Another thing we really like, there's a really good article published recently on prototyping with AI. And one of the things we really love is this whole spectrum of how you can prototype and really line up and make sure that you're fulfilling the user needs that you identified that really range from everything. Wizard of Ozing is really great for AI and ML, to using a functional subset of the data to kind of have some janky model outputs with something that can work. And then obviously you get to production level there. Okay, so that was the first one. The second one is we're going to look at the data collection and evaluation chapter. So this is also one where a lot of times user experience folks do not get into the data with AI and ML as much as they really should, because this is honestly where a lot of the impact into the user experience is going to happen. So the big thing to do here is translating user needs into data and making sure that our data sets have the features and breadth to ensure our AI meets our users' needs, all of our users' needs. We're going to talk about inclusion and bias in here. Should we use an existing training set or develop our own? And how can we ensure that raters aren't injecting error or bias in data sets when generating labels for supervised learning? Again, really kind of quickly, but just I know that the crowd can be really mixed in their exposure to this. So one of the things we talk about is like, what is data? So data can be lots of different forms, but there's some kind of canonical ones. So there's annotated text. So for any kind of language model, you might have, or for something like this, you might have a sentence and then labeling what part of speech each of these words are. You might have just something like interaction logs, like classic, what did somebody do on the website? That's really handy, or the device. You have labeled files. So this is supervised learning, where you have a number of examples that are given to raters who are humans, who either label something as a cat or not a cat, whatever it is that you're trying to determine. And then some like really interesting stuff. So this is an example of labeled data of whale songs that a team at Google worked with NOAA to better predict and identify whale songs across the ocean. So again, your role in data collection is, the training data source and how those data are labeled directly determines the AI system output and UX quality. And if the data that's used for the model is not aligned to the user need or the UX goal, you're just almost certainly not going to meet it. It's just it's a error that's almost impossible to recover from. And so what we're seeing a lot of times is people fitting solutions to a data set, not even a model, but a data set, because that is really the piece that underpins what's possible. And so data, the examples I gave right there might seem kind of simple or run of the mill. And you might say like, well, how can this be that different? Like, how can this be this challenging? And so I kind of want to walk us through a little example. We'll see how this works virtually. So usually in front of a live audience, you'd say, okay, everybody close their eyes and imagine a shoe. So please take a second, close your eyes if you're willing to play along, and imagine a shoe in your mind. All right. So this is also the part where raise your hand in your mind. So how many of you pictured something like this? Like a sneaker, or, like a Chuck Taylor, or like, something like this. I'm imagining hands going up. How many of you pictured something like this? A dress shoe, like a loafer or something. Okay. And then how many of you pictured something like this? A high heel, something usually worn by women in a more formal setting. Okay. So, we may not even realize the biases that we have, and this is one of those examples there. So when we do this, typically most people imagine the sneaker. That's the most hands that go up. And the fewest hands that go up are the high heels. And typically probably not surprisingly, the women in the audience are the ones that almost exclusively have thought of the high heel there. And this is a great example to show you that you may have a bias that you may not think about in any way, but that can filter its way into an ML model. And this actually happened with a really cool experiment called Quick Draw. So Quick Draw was an experiment, again, by our friends at the Creative Lab, that was had people go to a website and try to draw something, and an AI model would try to guess what it was. And it would use the different drawings to then try to make better guesses in the future. And one of the problems is the example I just gave, is that everyone, sorry, I'm gonna go back one slide, is that essentially everyone who went there in the beginning drew something like a sneaker. And so the model started to basically be drawn toward the sneaker and not recognize it when people were drawing high heels. So people essentially unaware of their own biases then injected that into the model. That changed its performance and made it perform more poorly for other people in the future. So another example of this that was really interesting is we're starting to see bias based on like region or culture. So these are just a sampling. So it's the same experiment, and they asked just people across the world, draw a chair, just draw a chair. And here are selecting a random 1,000 chairs from each of these countries. And you can start to see the slight differences there. So kind of take a look at the similarities and the differences. And one that really kind of stands out is Korea, right? So Korea is kind of a chair at a slight angle, whereas Brazil and the US and Germany and South Africa are more facing straight on. But even South Africa has a more variance, especially in the seat, than the other ones. And so we can see that something as simple as just draw a chair can start to have different biases depending on who is giving the data and who is labeling it and where they are, and what culture they come from. Another example here is something that was really interesting the Translate team did. So they were giving translations, and in some languages are gendered, some are not. And so what was happening is oftentimes they were, because of that, they were giving responses that were gender biased. So if you're doing Turkish to English, you say, he is a doctor. There was very unlikely for anything to say she is a doctor, because that's not marked in Turkish, is my understanding. Apologies if I got that wrong. And so they introduced a feature, I believe it was in 2019, where now that they're giving gender specific translation. So both she is a doctor and he is a doctor. But again, this is a way to intervene. On the left, it's just if you say pure data, we don't want humans involved. We don't want to really shape the model in the way that adheres to what we define as responsible AI. And on the right is actually the intervention in doing something there. So hopefully at this point you're thinking, I really don't want bias or unfairness in my model. So how can I help it? Well, there's lots of options. So I'm going to dive into one in particular. So there's things like fairness indicators, which are really at the building the model level. And if there's any developers in the audience, if you just use your favorite search engine and search for fairness indicators, you'll find our work there. But one of the ones I want to talk to you about that user UX folks and product people can influence but often don't think about are raters. So raters are the people who label data used to train really supervised learning, machine learning algorithms. And here's a picture of one of our rater centers. I believe is in Bangalore, India. And so what raters will do is go through tasks and label something, however the model developer would like the model to recognize. And so this is another kind of visual from one of our articles where if you're trying to teach, a model that can recognize different kinds of bread, essentially you use a bunch of experts or lay people's opinions and ratings and labeling of different examples of that, whether it's pictures or text or audio. And then, the model can then really start to recognize what are breads and what are not breads later on. Here's an example of one of those tasks. This is an old one, but it's looking at the difference between information found on Google Flight Search and another site. Here's one of my favorite ones, is that they'll show a picture to somebody and have them try to have the rater choose which of these examples reflects the hair in the color. So even here, there's a really human element, right, of which different kinds of hairstyles do you display to somebody, and where might your biases creep in, where you might think, oh, this is a good coverage of all the hairstyles in the world versus not. And this even shows up in things that are deceptively simple. So we might say something like, oh, I want a cat recognizer. So you say, please select all the images that show a cat. Well, the one on the left is kind of clearly a cat. The picture of the dog is kind of clearly not. Then you kind of get into these interesting examples of like, well, is an illustration of a cat popsicle a cat? Does that count? Are statues that are based on cats, do those count? Do tigers count? So even something as basic as that can be really challenging. And our role is often to really, what's interesting is it can really force a hard conversation on the part of the team of like, what do we mean by a cat? Okay, I'm probably not convincing you with the cat example. But when you get to simple things like you say, like, oh, we want to recognize, women versus men or something like that, this becomes extremely challenging as well. And it's challenging because you have to define really what do you mean by a woman there, and is the point of your model trying to detect something biological, something about expression, something about an internally held identity, which you frankly cannot predictably see using just images. And so even simple things that on the face, things that on the face seem simple become really challenging. And this is a big part of our job now, is to help define what we mean by these terms. And here's just kind of an example of that workflow of training, rating, adjudication, which is really important, which is basically when two raters disagree, and then model progress. So just to repeat this here, the training data sourced and how those data are labeled directly determines the AI system output and UX quality, and we need to align user needs with training data needs. And this is again, I'll reemphasize, this is a role for UX and product people to get more and more involved in with the data. So the last one I'm going to talk about is explainability. It's from our Explainability and Trust chapter. We've skipped a lot here, but let's say you've aligned to a user need, you have the right data, and now you have a working model. Well, one of the most important things is your model explainable, and do people properly trust it? And by properly trust, I mean you need to calibrate trust. So we need to calibrate user trust, and we need to think carefully about transparency and explainability. And we need to decide and then we need to decide how to display that confidence associated with prediction. So let's talk about calibrated trust. And here's an extremely simplified trust spectrum. So on one hand, you have no trust. The user doesn't trust the system in any way, doesn't trust the predictions at all. And on the other end, you have too much trust. So frankly, the user thinks the model can do things it absolutely can't. And what we're trying to do is land on calibrated trust. So as a user, I know what the system can do well, and I know when to use my own intelligence to correct the system. This is one of our favorite visuals of when trust is not properly calibrated. You have this beautiful expectation, and you get melty SpongeBob reality. So the basics of calibrating trust is really looking at what are the stakes. So what are the stakes at hand here, and should you basically try to get your user to, you're trying to get that right level, but if you can't get it, is it okay for them to over trust it a little bit, or would you rather them be very conservative? A lot of times in high stakes, you want them to be conservative. What system data are impacting trust in this situation, and what user knowledge is impacting trust in this situation? And then you really figure out the related explainability needs. I've never seen this not work in just doing good old-fashioned user research. Just talk to people, figure out how they're deciding how much they trust the system, and build around that. Then you kind of get to the point of like, okay, so then how much do we explain the system? You can't explain everything. You can't be fully transparent usually, because frankly, that would just dramatically interfere with the user experience. So there's two examples here. Like one is oftentimes spam filters use some form of machine learning now. You wouldn't want the ML-powered spam filter to tell you every time it filtered a spam message. That would defeat the entire purpose of a spam filter. Another example would be, say you're talking with a conversational agent of some kind or a chatbot, and it explained to you why it responded the way it responded every single time it responded. Like it would break it. There's no kind of conversation there. So this is kind of I won't go through this entire thing, but we kind of think of this as terms of user impact, low to high, and confidence of the system, low to high. And so in each of these conditions, we have some general guidance. This is all in the guidebook if you want to go check it out. And so let's say the user impact is high, but the system confidence is low. So I'm gonna go to the lower right-hand corner here. There we say the user should always verify the system's decision. Consider using explicit explanations, uncertainty displays, and a complete explanation. And if we go to maybe the lower upper left corner, so impact low and the system confidence is high. So the user should trust the system's decision with minimal explanation, and consider using something like an implicit explanation. That can be sometimes just a visual pattern versus a verbal versus a written text explanation, or no explanation at all. This might be something like you get suggested a song on your favorite streaming service. You probably don't need a huge explanation for everything. This is, again, one that I like to show that confidence can be a tricky thing. So going back to our teachable machine example, this is a model that Baron on that team trained. And so he has two classifiers here, one for him, one for his little kitty. Oh my gosh, I'm forgetting the name of it. Sorry, somebody will ping me in the text about that. And you can see that the model is actually having a lot of challenge determining which it is, and it varies by slight movements there. So here's where confidence would be important to show. And here are a number of confidence visualization approaches that really range from things like categorical, so showing the best match and then some good matches and lower, and best, which typically says, here's the best result that sorry, God, it's so hard not to anthropomorphize. Here's the best result based on our prediction, which again, imagine that's the top video you want to watch or something like that. And then here's some others. Numeric, so you can literally just say the confidence level as a percentage or 0 to 1. And then there's lots of data visualization options. I won't really get into those in there, but we have some examples in the guidebook. So again, those were the 3 chapters. There are 3 more that are on kind of classic human-centered design things like mental models, errors and failing gracefully, and feedback and control. So again, a reminder, we choose the data sources that we use, we determine the evaluation metrics and what success looks like, and we get affected by the results of all these models. So hopefully, I've convinced you here that AI has maybe not always been, but is human-centered, whether we recognize it or not. So let's start to recognize, honor, and act on that fact. Thank you very much, everybody. And I will exit out of here.
Thank you so much, Jess. That was super interesting. If anyone has any questions, please let us know in the Q&A box or the chat box. I know people are probably still trying to get their heads around that. But yeah, no, I've got a question for you, Jess. How would someone who's kind of typically a human-centered designer kind of get kind of more into the kind of AI side of things? Like, have you got any good resources you can share or anything like that?
Yeah, definitely. Yeah, there can be a lot out there, and so not to shill for ourselves, but we think that a lot of what we put out is some of the stuff that's very accessible. So pair.withgoogle.com is some of our starters. If you look, Google also has an ML crash course. If you want to get into the details, the technical details more, write a little bit of code, that's a great resource. There are things called ML cheat sheet, which is another one that I think explains a lot of the concepts really well and breaks them down. And one of the things I just try to reassure people of or tell people is that the field of ML and AI is like sailing. So you may actually already know what a lot of these concepts are. They just decided to rename them for some reason. So I'm a social psychologist by training, and I have a pretty decent stats background. And as soon as we started to, when I first started to dig into all this, you realize that they just kind of call, one concept another thing. So don't be too intimidated by the terminology too. Try to dig in where you can. How are we doing? Are we having some technical challenges?
It's over on Twitter. It's just there on
Shoot. Oh, okay. Let's see. Oh, I'm the host now. Okay, I believe everyone can still see and hear me. Oh, I had the question.
Cool. Sorry about that. Yeah, we're having a few internet, but there's no more questions in the chat. But yeah, thank you very much. Yeah, if anyone yes, no over on Twitter, and I'm sure you'd be happy to answer them. And yeah, I'll
yeah.
Oh, actually, yeah, we have had one question just pop up.
Okay.
There's currently a proliferation of AI guidelines, governments, institutions, etc., from all around the world. How do you think those relate to the more tactical guidelines by pair? And that question's from Reza.
Thank you, Reza. I appreciate that. Yeah, there's a lot of. First of all, there's a lot of them. It's challenging to keep up with them, to be honest. And we tend to kind of look for the commonalities in them. They vary tremendously in how much you can act on them or not. And some are meant to be more philosophical guides than not. But we look at things that are common to them and then try to frankly build something useful relative to that. So if you look at something like the what if tool to examine data, I don't think any of them say anything. Probably every single one of them says something to the effect of not introducing bias into data sets, or them being fair or inclusive or something to that effect. And so then you build a tool that allows you to inspect your data for that. I think every single one of them says something to the effect of, AI or ML should be used for good or to help people with their problems or something along those lines. And so we, write a section of the guidebook that's all about user needs and aligning to that. So we try to kind of, see where the overlap is. And frankly, there's quite a bit, I think every single one of them mentions, transparency in some way. And so then we try to do research on how we might do better explanations, especially of models that have that are still hard to explain at every single level. So we kind of treat those as almost guidance and trying to see what everyone cares about. But then we try to find the commonalities and then try to build something useful that's going to address multiple of those at once.
Awesome. Thanks very much, Jess. No, thank you for presenting. We've just had one last question come in. I'm wondering, what are your thoughts on AI being able to create the best UX itself? Do you see the future going towards that? And that's from Giselle.
Yeah, thanks, Giselle. Yeah, I definitely think. Oh, and I'm seeing some pop up in the chat too. Yeah, I definitely think AI assisted design is coming for sure. There's some early examples of that, and we have some stuff that's around like pretty narrow targeted use cases. So there's things that can pretty already create like an ad campaign, like a small ad assets based on a website or something like that. And I think that we're going to see some assistance coming. One of the pieces of research that I really enjoyed, and this is years old now, but was really about it was actually around where designers would want AI assistance and not. And so I think that we're going to see adoption in things just like basic version control and things like that. But then I think most, as AI kind of evolves, it becomes this like really interesting kind of assistant who can bring you lots of options. So our role becomes more curator than creator at times. So imagine, you're kind of brought like 8, you almost give a verbal description of what you'd like to design, and you're brought like 8 different options, and you have the ability to kind of like tweak it like weirder, more out there, more minimalist, more brutal, like whatever you want to do. And it starts to play with it. And you probably wouldn't use any of the outputs that it would provide, but it would be almost like a provocation or a brainstorm. And some of the places we're most interested with that is still when people are connecting with people, but it's AI assisted. So we've all been in like a brainstorm or a meeting where it kind of like, things are going well and then kind of the energy drained and nobody can kind of like come up with anything. And like, imagine, you kind of have the AI as like an annealing agent that kind of like disturbs the state of the thing for a second. You're like, oh, that's kind of interesting. Wait, what if we did this? So it looks a lot, I think, more like that. Like, hopefully it's something like AI is augmenting an already social collaborative process.
Thanks very much, Jess. The next
Yeah.
one here, I've been doing a lot of work with users to explore what they want from AI. Your statement to use user research methods is interesting. I found that standard user research is inappropriate, as getting everyday people to explain abstract and complex is challenging. Thus, we have found design thinking and arts practice get more effective in design and exploring AI with non-experts. Could you explain what you meant in terms of user research?
Oh yeah. So user research can really span many different things. At the most basic level, I'm a big fan of talk to 5 people who aren't on your team. That's at the very, very basic level. Running by, it depends on where people are. Ideally they're trying to listen to people, be proximate to people. So this doesn't, user research is not asking people what they want. User research is understanding, what people's needs are, but also what their aspirations are. So typically, people aren't buying your product, they're buying a better version of themselves. And so you're trying to understand, we spend a lot of time trying to understand, frankly, like who people want to be, like what kind of life they're trying to achieve, who they're trying to become. And we can only do that, frankly, through a lot of observation. So this means, getting out of the office, being with people. And I know that that's extremely challenging right now. We've been had to halt a ton of research and do a lot more remote research, but there's some really interesting platforms for doing like diary studies or connecting with people in that way. And then really building on what you see and hear and frankly, like can triangulate from different people. And then I'm also a believer, like I said, in it's kind of challenging. Sometimes I feel like I'm, there's another talk where we like thread these things together, but a lot of times there's a need for invention as well. And we heard this thing, nobody directly asked for it, but we think that this is the thing that they need, and you invent something. And then of course you have to run it by people. And I'm a fan of saying like everyone goes through the human-centered design process. You just get to choose when. So at that point, you can run your product by people before you launch. You can spend the money to run it by a small group of people and probably learn some really valuable things, or you can launch it and see what the market says. But either way, you're going to get evaluated by people at one point, and it has different costs associated with it, depending on the choices you make and what makes sense for your business.
Awesome, thank you very much, Jess. And we have one final question here from Simon. What are the AI skills you feel are missing in the industry, and what are the hardest to recruit?
Ooh, that's a really good question. Thank you, Simon. I think a lot of it is these bringing in more of the social sciences. And one of the things I see kind of missing, it's interesting, there's a flood in right now in a lot of ways around like ethics and almost humanities, which is also important. There's oftentimes a solid gap in between, the developer making the model and and something that's at the level of like almost a philosopher or ethicist or something like that. And so, I'm biased, but I think we need more of like where pair sits, which is this like integration layer between the two. So one of the other things we found is that oftentimes social scientists have a very strong experimental design background, understand the fundamentals of just the scientific process and everything like that. And that is really needed to ground out a lot of these models in what we know from social sciences. And then I also think you do need an aptitude to pick up the technical aspects. I believe it's all learnable. I believe it's all trainable, but you have to want to get deep into the details of the technology. I think the influence of any UX or a product person is going to be very limited if they don't actually get into the technology. And I don't think that's like all that different than any other platform or paradigm. that we've come across. And then what other? So yeah, I think it's interesting to try to find these folks who, we're also just recruiting. We're trying to find people who are traditionally misfits, or traditionally don't line up really well. I say sometimes, like, we really want to occupy the seams. We want to be across a couple different roles. And so there's another person on our team who, great researcher, but also can prototype very lightweight ML models and has a background in cognitive neuroscience. Like, I would take 5 more of her in a second, because they can kind of explore the space. They can discover user needs, but they can also invent. And that's really what we're looking for, because this is an exploration space. If you take an explore and exploit model, like, we're doing a lot of exploring, and we need people who are able to explore with a lot of different tools.
Awesome. Thank you very much. Well, no, thanks so much for your presentation. Apologies for the technical difficulty.
No worries.
Yeah, we'll leave you to enjoy your morning coffee.
Thank you.
Thank you very much, Jess. Thanks everyone for
Great. Thank you very much. Thank you, everyone. Appreciate your time.
Thank you.
Bye.